In class 9, you have learned about various elements. You have seen that elements can be classified as metals or non-metals on the basis of their properties. Now think of some uses of metals and non-metals in your daily life. What properties did you think of while categorizing elements as metals or non-metals? And how are these properties related to the uses of these elements? Let us look at some of these properties in detail. The easiest way to start grouping substances is by comparing their physical properties, and first of all, let's see the physical properties of metals. Most of the metals are hard except alkali metals such as sodium, potassium, lithium, etc., which are very soft metals. These metals can be cut even by using a knife. Most of the metals are strong and have a high tensile strength. Because of this, big structures are made using metals such as copper and iron. And to talk about the state of metals, metals are solid at room temperature except for mercury, which is a liquid. Metals produce a ringing sound on striking it with a hard surface, and this property of metals is called as sonority. This is the cause that metal wires are used in making musical instruments. Metals are also good conductors of heat and electricity, and this is why electrical wires are made of metals like copper and aluminum. Metals are malleable, which means that metals can be beaten into thin sheets, and because of this property, iron is used in making big ships. Metals are also ductile, which means metals can be drawn into thin wires, and because of this property, a wire is made of metals. Now coming to its melting and boiling point. Metals have generally high melting and boiling points except for sodium and potassium, which have low melting and boiling point. And most of the metals have a high density. And generally, metals in their pure state have a shining surface. Elements can be more clearly classified as metals and non-metals on the basis of their chemical properties, and let's see some of the chemical properties of metals. The first one is the reaction of metals with air. That is, when metal reacts with oxygen in the air, you get metal oxide. For example, you react aluminum metal with oxygen, you get aluminum oxide. If you react potassium with oxygen, you get potassium oxide. We have learned that metal oxides are basic in nature, but some metal oxides such as aluminum oxide, zinc oxide, etc. show both acidic as well as basic behavior. And such metal oxides which react both with acids as well as with bases and produce salt and water are known as amphoteric oxides. All metals do not react with oxygen at the same rate. Different metals show different reactivities towards oxygen. Metals such as potassium and sodium react so vigorously that they catch fire even if kept in the open. Hence, to protect them and to prevent accidental fires, they are kept immersed in kerosene oil. At ordinary temperature, the surfaces of metals such as magnesium, aluminum, zinc, lead, etc. are covered with a thin layer of oxide, and this protective layer prevents the metal from further oxidation. The metal iron does not burn on heating, but iron fillings burns vigorously when sprinkled in the flame of the burner. Copper does not burn again, but the hot metal is coated with a black colored layer of copper 2 oxide. Metals such as silver and gold do not react with oxygen even at high temperatures. Coming to the second reaction, which is the reaction of metals with water. When metal reacts with water, you get metal oxide plus hydrogen. And when metal oxide reacts with water, you get metal hydroxide. Metals like potassium and sodium react violently with cold water. In these cases, the reaction is so violent and exothermic that the evolved hydrogen immediately catches fire. The reaction of calcium with water is less violent. The heat evolved is not sufficient for hydrogen to catch fire. You would notice that calcium floats in water. Now this is because the bubbles of hydrogen gas formed stick to the surface of the metal. The metal magnesium again does not react with cold water at all, but it reacts with hot water to form magnesium hydroxide and hydrogen. Magnesium also starts floating due to the bubbles of hydrogen gas sticking to the surface. Metals like aluminum, iron and zinc do not react either with cold water or with hot water, but they react with steam to form metal oxide and hydrogen. Now metals such as lead, copper, silver and gold do not react with water at all. And I think now it will be clear to you why ornaments, that is jewelry, are made up of gold and silver mostly, because they do not react with water nor with air. Now coming to the third reaction, which is the reaction of metals with acids. Metals react with dilute acid to give salt plus hydrogen. For example, you react sodium with HCl, which is hydrochloric acid, and you get sodium chloride plus hydrogen. The metals copper, gold and silver are known as noble metals. They do not react with water or dilute acids. The order of reactivity of metals towards dilute HCl or sulfuric acid is in the order potassium, sodium, calcium, magnesium, aluminum, zinc, iron, copper, mercury and silver. Now we saw that metals react with acid to give salt and water, right? However, hydrogen gas is not evolved when metal is treated with nitric acid. That is also an acid, but hydrogen is not evolved. Why would that be? This is because nitric acid is a strong oxidizing agent and it oxidizes the hydrogen into water and itself gets reduced to some oxide of nitrogen like nitrous oxide, nitric oxide or nitrogen dioxide. Now coming to the fourth reaction, which is the reaction with solutions of other metals. Reaction of metals with the solution of other metal salt is called as displacement reaction. In this reaction, a more reactive metal displaces a less reactive metal from its salt. For example, if you react metal A plus salt solution of B, you get salt solution of A plus metal B, which means there is displacement taking place there. Let's take an example. Iron displaces copper from copper sulfate solution because iron is more reactive than copper, and the equation is as follows. Fe plus CuSO4 gives rise to FeSO4 plus Cu. In order to get a clear idea of displacement reaction, we need to know what we call as the reactivity series, wherein metals are placed in the order of their reactivity from high to low, with potassium being the most reactive metal and gold being the least reactive in that series you see. Now to summarize, metals are generally hard, sonorous, malleable, ductile and conducts electricity. And the chemical reactions of metals that we discussed includes reaction of metal plus oxygen giving metal oxide, reaction of metal plus water giving metal oxide plus hydrogen, reaction of metal plus dilute acid giving salt plus hydrogen, and the reaction of metal A plus salt solution of B giving rise to salt solution of A and metal B.